Hello friends, I'm Kamal Kumacha and welcome you to my channel Talent Care Educations. So in this video you're gonna learn about the basic properties of a circles, because in the last videos I have told you some introductions about the circles, and in these sections we are gonna learn about the theorems and we will solve some questions related to those theorems. So let's start. So this is a circle and this is the center, right? If we take 2 points A, that this is A and this is B, and if we join those 2 points across the center, so this is our diameter, right? And we know a basic properties about a diameter, that a diameter is the longest chord of the circle, right? And the second thing is that a diameter divide a circle into two equal halves. Okay, it divides the circle into two equal half, right? So if we will erase this part, so it will become a semicircle, right? This is called semicircle, right? So if we will take another point P in the circumference of the circle, and if we will join this point, so it is looks like a triangle, right? It is a triangle. So the angle formed in such a way is always will be 90 degree, right? The angle will be 90 degree. So we have what? So we have angle APB equals to 90 degree. So this is our theorem 4. It said that the angle formed in a semicircle through the chord into its circumference is always will be 90 degree. So angle APB will be 90 degree. So in your exams you're gonna see such types of questions related to this theorem. For example, this is a circle. Okay, so you have to find the angle ABP. So what will be the value of angle ABP? So through this theorem we know that this is a chord and chord divide a circle into two equal halves. Okay, so from theorem 4 we know that our angles on a semicircle is always 90 degree. So in triangle APB, angle APB equals to 90 degree, right? Because angle in semicircle, right? And both of the chords are equal, so equal chords makes equal angle. Say if it is x, so this angle is also will be x. So now on solving these questions we will find that angle PAB plus angle ABP plus angle APB equals to 180 degree, sum of three angles of triangle. So this will be x plus x degree plus 90 degree equals to 180 degree. So 2x equals to 90 degree, x equal to 45 degree. So we have the value of x, that is the angle will be 45 degree and this will be also 45 degree. So you have seen that in a very easy way we can solve those questions if you have a basic knowledge about the theorems of a circle. Okay, next is okay, so moving to the next point, our next question is that if in a circle. This is a center. Let's draw a chord AB. Okay. So if we will put a perpendicular from the center to the chord L. So if we will draw a perpendicular from a center to the chord, so the chord will be divided into two equal halves. So it means L will equal to B1. This is our theorem 5. Okay, it says that if a perpendicular is drawn from a center to the chords, so the perpendicular divides the chord into two equal halves. Means this and this side will be equals. Let's prove this thing. If you will join OA and OB, so you will get two triangles. Okay, it means in triangle OAL and triangle OLB, right? So we know that OA will equal to OB because both are radius. If it is R, so it will be R also. So OA equal to OB. We need to give the reference that these are radius, right? Now OL equal to OL, common है, okay, and it is said that this is a perpendicular, so this must be 90 degree, right? So angle OLA equal to angle OLB equals to 90 degree. So thus triangle OAL equal to triangle, it is congruent triangle OLB. Okay, so AL equal to BL from CPCT. Okay. Next theorem is I have said many times that if two chords are equals in length, let's suppose this is C and D and this will be A and B, right? If AB equal to CD, if AB chord will equal to CD, okay, and this is the center, then both the chords will be equidistant from the center. I repeat, if it is said that two chords are equal in length, then the two chord will be also equidistant from the center. How? So let's see. If you will join point OL and OM, so both OL equal to OM. OL and OM will be equidistant from the center if and only if the two chords are equal. Okay, so this is our theorem 6. Okay, it is said that in a circle, if two chords are equal in length, then they must be equidistant from the center. यानी सर्कल से ये बराबर दूरी पर होगी. Okay, let's move to the next one. Next one is said that let's suppose this is the center, right? Let's take 2 points in the circumference of the circle A and B. Let's join them. This is O. So OA and OB. Okay. So OA and OB must be the radius of the circle. Okay. And AB will be the arc. AB is a arc of a circle, right? This is the arc of a circle, this portion. So it is said that the angle drawn from the arc of a circle to its circumference, okay, angle drawn from an arc of a circle to its circumference is always will be the half of the angle found in the center. What does it mean? It means that let's take 2 points A and B in a circle, and O is the center, and if we will join, let's take another point P over here. into the circle. Let's join these 2 points. Right? So it means this AB is an arc, okay, and let's take a point over here on a circumference of this circle. If we will join this, we will get an angle like angle APB. So from theorem 6 we know that angle APB will be half of angle OAB, angle AOB. So this is our next expression, that theorem 6. It said that if we will take 2 points in a circle A and B such a way that these will be the arc of the circle, and if we will take another point over here on a circumference of a circle and join them, then the angle formed in the circumference of a circle will be half of the angle formed in the center of the circle. That means if the angle of a center will be theta, then it must be theta upon 2. Okay, let's take an example. Suppose that it is given that this is a 50 degree, right? Let's take a 60 degree. It is asked to find the value of x, that means value of angle APB equal to what? So we know that from equation, the given equation which I have proved right now, so we know that from the theorem that angle APB equals to half of triangle AOB, right? It is given that APB equal to half of the value of AOB is 60 degree, so into 60 degree divided by 30, so APB equals to 30 degree. Okay, so in this way we can easily calculate the values of angles through the theorems if you have the basic knowledge about those theorems. Okay, let's move to the next point. So our next point is that if we will take again 2 points A and B, and let's join them, AB. Okay, so this portion will be the segment. Okay, so our theorem 7 is that angle formed in a single segment is always will be equal. So it means that AB is a segment, and let's take a point C over here. Let's take another point D over here. So the angle, both of the angle will be equal. It means that angle ADB will equals to angle ACB. I repeat that angle formed in a same segment is always will be equal. So both have the same base AB. So AB is the segment, okay, over that angle ADB and angle ACB is formed. Okay, so in such way angle ADB and angle ACB will have equal values, right? Let's take an example. So if this will be 30 degree, find the value of this one. So from theorem 7 we know that angle ADB will equal to angle ACB. So both have the value of 30 degree, right? Okay, now move to our next point. Let's move to our next point. Our next point is that if we will draw a circle over here, okay, and let's draw 2 chords AB and CD. Okay, let's join them in such a way that it will form a quadrilateral ABCD. So we have ABCD is a quadrilateral. ABCD is a quadrilateral. If we will produce one side of this quadrilateral, let's produce AB to E. So angle formed in the exterior of the quadrilateral DBE will be equal to the angle opposite to this, that means angle ACB. That means angle ACD will equal to angle DBE. DBE. Okay? Note down this in your copy. So let's take an example. If it is given that angle ACB is 60 degree. Okay? ACB is a 60 degree. Then find the angle of, and this is also given that this is 110 degree, right? And let's take it 70 degree. Then find the value of what? Find the value of angle ACB. So we know that this is a straight line, and a straight line has 180 degree. So if you will minus 180 degree minus 110, we will get 70 degree. Then this will be 70 degree. If angle DBE is 70 degree, then we must have angle ACD will also have the equal value, that will be 70 degree. So in this way, we can easily calculate the values of such types of questions. Okay? If, I repeat, if and only if you have the basic knowledge about all the theorems of the circle and about the geometry. Friends, let's discuss about the next point, in circle of a triangle. What does it mean? In circle of a triangle mean that if a circle touch the side of a triangle, if a circle touched the side of a triangle, A, B, C, D, E, F, in such a way. Okay? If a circle touches the side of a triangle, then the circle formed in such a way is called the incircle of a triangle. So from this theorem we will get an equation, right? And the equation is that CD will equal to CF, AD will equal to AE, and EB will equal to FB. That is, CD equals to CF, our first point. Next is that AD will equal to AE, and BE is equal to BF. Okay, note these things on your copy. Okay, I repeat that this is called the incircle of a triangle, that if a circle touches the side of a triangle, okay, then the circle formed in this manner is called incircle of a triangle. So from this theorem we will get this equation, that DC will equal to CF, and AD will equal to AE, and BE will equal to BF. Okay, next thing is that tangent. What is tangent? If a circle is drawn over here, let's take center O. Let's draw its radius OP. Okay, so P is the last point of the radius. Okay, if it is R, right? From this point, if we will draw a line, in such way Let's the line is AB. Then the line AB will be called the tangent of a circle. Okay, this will be called the tangent of a circle. That means if a line is drawn from the last point of the radius of a circle, then the line is drawn in a way is called the tangent of a circle. Okay, so we will get a properties through the tangent. Okay, this is what we call tangent. Okay, let's take another example. If we draw a circle over here, okay, let's take center O. Let's take another point P over here, okay, and meet the point P. P, okay. This is A and the point is B. Let's join them. O and OB. This will be perpendicular. Okay. So it said that if a tangent is drawn from a center exterior to the circle, from a point exterior to the circle, then the length of both of the tangent will be equal. It means PA will be equal to PB. Okay, this is our equations, that PA will be equal to PB. Okay, next. Friends, let's discuss about our next point. Okay, if a circle is drawn over here, let's center is O. Okay, and if we draw a chord AB and a tangent, we know that a tangent is a line that is passed from a very last point of the radius. Okay, so let's take this CD, C and D, and this is P. If we will join them, in a way, this will be 90 degree, right? Let's take another point C over here. Okay, so AB is our chord and CD is a tangent line of this circle. So it is said we have this equation that what equation we will have? We will have equation that PB, that means PA into PB equal to PT square. Okay, what is PT square? Let's take this T. Okay, so this is the equation. So in this way you have seen that we have completed all the theorems of this circle, and in the next part we are to solve a lot of questions related to this theorem of a circle. Thank you.